In the hunt for more ways to recycle plastics, Little Blue may provide another option. Plastics are globally recognized as ideal materials for addressing everyday human needs, from drink containers to auto parts. With this popularity comes the fact that plastics make up about 1/5 of the volume of trash that goes into our landfills. To reduce the level of landfill-bound material, companies in the United States, like those in other countries, are looking for new ways to recycle products and conserve resources. Plastic's versatility and performance have made it the choice of product manufacturers. To increase the environmental performance of its products, the plastics industry is researching and developing advanced recycling technologies.
The demand for plastics has been increasing. At the same time, the demand for recycling has been increasing. But plastics inherently are difficult to recycle because there's so many different types.
Well, by all indications, used plastic consumption will continue to increase. And along with that increase will be an increased demand for advanced recycling technologies. Now, mechanical recycling hasn't met that bill.
In the United States, over 6,800 communities are diverting more and more plastics into recycling programs. Recycling this material involves many steps: sorting, shredding, cleaning, melting, and finally, they are shaped into pellets and sold to a manufacturer to be made into new plastics. Current uses for recycled plastic include new bottles and numerous other products. But making these requires a clean stream of post-consumer plastic. Another challenge is the high cost of collection and the fact that recycled plastics must compete with lower-cost virgin plastics. These are just some of the reasons to search for new and complementary recycling technologies that are capable of processing a number of different plastics with little sorting or cleaning.
Recycling plastics frequently cost more than make new plastics. Because of that, we need a variety of different recycling processes so that we can continue to meet the needs of society, continue to conserve natural resources.
Conrad Industries is developing one type of advanced recycling technology that adds a new tool to the mix of available recycling solutions. The process turns plastics back into raw materials for the production of new products. The transformation is currently taking place in Conrad's Advanced Recycling Unit, nicknamed Little Blue. Little Blue is a research and development machine that uses heat to reverse the process of manufacturing certain plastics. It actually turns them back into their original building blocks.
The Conrad unit, on a commercial scale, should be able to recycle about 3,000 pounds an hour of plastics. That's an order of 25 million pounds of plastics a year, which is a fairly small facility. We think there's a beauty to that. In recycling, I think small is going to be beautiful. You're going to want very small facilities close to the source of plastics, and that's one reason we're so excited about the Conrad process.
The Conrad system works like this. Plastics are heated and vaporized in the absence of oxygen, which prevents combustion. This process is called thermal depolymerization. Once vaporized, 70 to 80% of the reclaimed plastics are converted into liquid petroleum products, the raw materials of plastics and many other products. A small amount of carbon is also produced in the process, as well as a light gas that is used to heat the recycling unit.
Conrad Advanced Recycling Technology is very similar to processes used to recycle glass, steel, and aluminum. Basically, we're taking post-consumer plastic and breaking it down into feedstocks of oil, gas, and carbon. The oil is very similar to a crude oil, but actually has higher value, so we can send that oil back to a refinery and upgrade it to higher value petrochemical feedstocks. Similar thing occurs with the carbon. We can take the carbon and upgrade it to higher value, such as activation for filtration purposes, or even use it back into new rubber and plastic goods. So it has environmental benefit, and that's the beauty of this technology, is we can take an environmental problem and convert it to an environmental good.
This system is very tolerant and generates little or no waste.
We're very excited about the advancements that we have made in this technology in the last few months. What we're doing is taking, through this advanced recycling technology, taking waste streams that up to now have been unable to be recycled.
To ensure a quality product and an environmentally safe operation, the Conrad system is continuously monitored by engineers and technicians.
Each oil sample and each gas sample is what we call a fingerprint of the process conditions as a whole, and that fingerprint tells us a lot about what the process conditions are that we're operating with, what type of plastic we're running at the time, or what type of mix of plastic we're running. And that fingerprint lets us know whether we're running smoothly, whether we have a trouble spot we need to watch in the machine, or whether there's a new set of conditions that are developing that we need to become excited about or look at more closely. We have set up on Little Blue the little distillation apparatus, a lab bench scale distillation apparatus that condenses a fraction of oil directly from the inside of Little Blue. We then take that oil sample and we make a small GC gas chromatograph vial of that sample, and I place that here in the sample tray, and the auto sampler does its thing, and it automatically injects that oil sample into the machine. And the gas chromatograph then goes through and does the analysis.
The petroleum-like oil that is produced by Little Blue is loaded into tanker trucks and shipped to a refinery. Once refined, it can be manufactured into fuels, synthetic fibers, and new plastics. This new recycling technology being used at Conrad does not compete with conventional plastics recycling programs. It can recycle those plastics currently not recycled by other means. Versions of this technology are being evaluated in Europe and Japan, where they are viewed by the public as plastics recycling. These technologies are used to convert plastics back to building blocks for new products used by industry and consumers. The technology that will be demonstrated today offers the opportunity to recover a greater quantity and variety of plastics for reintroduction to the marketplace.